Hey folks, Bob Warfield here. Just going to give you a quick demo of two of the more popular entry-level CAM programs so you can get an idea of how they work and maybe a quick introduction for beginners who've never used CAM that'll save you some trouble. The first one I'm going to demonstrate is called MeshCam. MeshCam is from GRZ Software, and it's a product that we resell, and its focus is to be super simple to use. We've skipped a lot of fancy options that you're just not going to need early on, and just really tremendously simplify the user interface so that it's quick and easy to produce parts using MeshCam. By the way, this is the software that's used with the Carbide 3D Nomad CNC mill, which was recently a big success on Kickstarter, which again, the idea is they're bundling the software and the hardware all together and really making it simple to do things. So what I've got is a sample part, and let me go ahead and bring that in, that I've created as a 3D model in Rhino 3D. It's a carb spacer for whatever that's worth, but it really doesn't matter. It's a pretty common type of part that's often referred to as 2.5D. It's flat on the top and the bottom. It's a 1/2 inch thick. We're going to machine it out of plate. And so what we basically want to do is have a piece of plate that's a little bit bigger than this and machine away all the material that isn't the part. And so having imported the drawing, I'm presented with a few options in MeshCam that are pretty cool. We can do two-sided machining with tabs. We can run a 4th axis, but I'm just going to do the simplest possible thing. I'm going to do a 3-axis here. And then the next thing is to go through a series of questions. And this is very common for CAM programs. What's a little bit unusual, though, is these questions are organized in a particular order here. You don't have to stick to that order, but MeshCam's author has gone to some trouble to try to make it simpler. So we'll start out defining the stock. That's the block of material you're going to start with before you have anything else. And so it'll just shrink fit to geometry an exact size block. But I want to go ahead and add a little bit to the Z, the thickness of the part. I'm going to make it 5/8 instead of exactly 1/2 inch, so that we have room to machine them at the top of this plate and get a nice precision fit. I'm going to ignore the rest of this. It's not really necessary for a part like this, but it is available for you. And I'm going to go on to the next one. We're not using the support options, so I'm not going to bother with that. Retract height just says when we get ready to move the cutter to a different place, how high should we raise it above the part? And 1/10 of an inch is a pretty common number for a default. I'm just going to leave that default alone and not bother changing it. Program 0 or part 0, as some people prefer to call it, is where the coordinates are at 0, 0. And by default, it's the front left corner here. You can see this little coordinate gadget. Again, it's nice to be able to change that, but we're not going to mess with it for this particular part. Maximum depth. We want to go all the way down through this 5/8 inch thick plate to the bottom, so we got to put 5/8 inch. The machining region, again, we're not going to try to machine some subset here. We're going to do the whole thing, so I'm just going to ignore that. And then the very last pick says generate the toolpath. Now, lots of little options here that you could use. What I'm going to do here is forget about a finish pass. I am just going to do a roughing pass so that we can kind of see the whole thing. So I've left the finish pass off. I've got a tolerance of 1/1000 of an inch. If it needs to take a shortcut or something, it'll make sure it never gets more than 1/1000 of an inch off of the actual model. We got a roughing pass. It's coming up with defaults. I tried this before I recorded it, but it's easy to select a tool until I have a 1/4 inch tool. How much do we want to cut per pass? What's the step over, the feed rate, the plunge rate? these are questions that are interesting, and that you probably wonder how the heck you're going to come up with the answers to those questions. One thing about CAM software is it's always got a lot of questions to ask, and it's helpful if you can get some assistance with those questions. And so, again, the defaults are there, but I'll just show you very quickly. I used um, our GWizard software to come up with those answers, and I came along and I said, well, we got some aluminum, we got a carbide end mill, we got a 1/4 inch diameter tool, cut depth. I'm going to go all the way through 5/8 of an inch, and the width, I'm going to use the full width of the cutter. Just, keep this all very simple, and, away we go. We get various answers for what our feed rate and all of this sort of thing ought to be. And so if you're wondering where to get the answers to put into your CAM software, GWizard is a good source of that. So we'll leave all of that in place, having figured it out in GWizard a little bit earlier. And there's plenty of other videos on our site you can go if you want to see how GWizard does that. But just be aware that if you've seen a lot of these kind of questions of, how deep to cut, what step over to use, what feed rate, what plunge rate, these are all the types of questions that GWizard is designed to help you with. So I'm going to use 3D roughing. It's the default. Again, I'm just using the defaults in this program. And I'm going to hit OK. And just move this aside. You can see, well, now we've got a toolpath that would cut out this part. And so I want to save that toolpath. And I'm going to save it in a MeshCam file here. MeshCam carbspacer.nc is actually a G-code file. And we're going to overwrite it. And yeah, that's basically all there is to it. We're done. We've created some G-code. And if you want to have a look at the G-code, let's see here. We can use our that's calculator again. We can use our GWizard editor product, which I'll bring up, and just load the G-code file in here. You can see I've already been messing with it, so let's load the carb spacer, and here you can see what actually the G-code is going to do. And you can kind of see it just goes round and round and round, and starting at the outside and working its way in, and it goes down in the areas where the material needs to be cut out, and it goes up where it needs to avoid the part, and basically it covers all the different surfaces. And if we want to take a look at how long it'll take, we use the info tab, and 4 minutes 55 seconds, roughly speaking, right out of the box. And so, I've done nothing to try to optimize the software or anything like that. It's just come up, and it's been, pretty quick and easy, and away we go.